All right, class, welcome back to the last part of section 2.5, so the last part of chapter 2. Okay, minimizing inventory costs. So I actually made up a really nice story in your textbook. Please read that. So what are minimizing inventory costs about? So let's read this problem and see if we can figure it out. It says, the supermarket expects to sell, let's say, 4,000 boxes of sugar in a year. Each box costs $2, and there's a fixed cost for delivery of $20 per order. If it costs $1 to store a box of sugar in a year or per year, what is the order size and how many times per year should the orders be placed to minimize inventory costs? Okay, all right. So what does it mean to minimize inventory costs, and what are inventory costs? So let's think again. So this supermarket is going to sell 4,000 boxes of sugar in a year. Now, does that mean that the supermarket should be ordering all 4,000 boxes of sugar on January 1st and then slowly sell all of those and then come again January 1st? Order another 4,000 boxes of sugar, and so on and so on? Or would there be a bit better plan? The thing is, you should not be ordering or store and keep in storage everything you plan to sell in a year. Why? Because there's only a limited amount of storage in every supermarket, yes? The thing is, though, and look, it says $1 to store a box for the year, yes? The other thing is, well, should you just keep ordering every month, right? Whatever 4,000 divided by 12 might be, and you order maybe, or let's say order 100 and order 100 again? Not really, because it costs you $20 every time you are ordering, right? There's a delivery cost. So you want to balance this. Don't order too many at a time, yes, because you're going to have to store it and there's no room for storage. Don't order too few, because then you'll have to keep reordering and pay this delivery cost every time, yes? So you want to find a balance in order to do what? Minimize inventory costs. So let X be the now. So the question is, how many boxes of sugar, in this case, should we have per order? So how many will we order at a time? What's the order size? Should we order 1,000 at a time 4 times a year, right? Should we order 2,000 at a time 2 times a year? Or maybe 500 boxes goes in 8 times a year, right? Or 140 times a year. That's crazy. Okay, so that's called the order size. Okay. So let's see what costs. We want to minimize the cost, yes? Okay, so it looks to me like the cost is made up of 2 different things. First of all, there's storage costs. And again, that's why we don't want to store too much at a time. Plus, reordering costs. Right, so, but also we don't want to reorder too many times, yes? So it has to be a balance. Okay. Now, what are the storage costs? Let's look at that. It says it costs $1 to store a box for the year. The thing is, how many boxes? I mean, are you going to have all 4,000 boxes there the whole year? Not really, yes? Are you going to have $10 of boxes for the whole year? No. What happens? So think about the storage. How many boxes do you have in storage at a time? The thing is, on January 1st, you order 10 X boxes, yes? And then what do you do with these X boxes? You start selling them, yes? Until you got to 0 boxes, yes? And then what do? Order X more. And then you start selling them until you get down to 0. Order X more. And start selling them until you get down at 0. So about how many boxes are there in storage at a time, right? On average for the whole year. You don't have X. You start with X, but it goes down to 0. You don't have 0, right? So let's say you're ordering 100, yes? Not all 100. You're not going to have 100 boxes in your store for a year, right? You start at 100, and then you might have 90, 80, down to 0, yes? So what I'm saying is that on average, you have about X over 2 many boxes in storage. So about half of what you're ordering, yes? So you might start at 100. At some point you might have 100. At some point you might have a 0. That's on average about 50, yes? You might have 90. You might have 10. That's an average of 50. So you have on average about half of your order size boxes in storage per year. So what are the storage costs? Well, number of boxes of sugar times the cost per box, which for us is, as we just said, how many boxes of sugar do we have in storage? About X over 2. What does it cost to store these? It costs $1, yes, cost $1 to store a box for the year. So we have on average, let's say about 50, right, in storage. Plus, what are the reordering costs? So what do we pay every single time? Well, clearly the $20, yes? Yeah, I'm going to write this down. So I'm going to write cost, sorry, I'm going to write number of orders times the cost per order. These are the reordering costs. So we have to figure out what are the costs per order every time, but we don't just order once, yes? We order multiple times a year, right? So let's see what this is. First of all, I'm going to look at the cost per order because I like that better. So what do we pay every single time we order? There's a fixed $20 clearly delivery charge, yes? Okay, what else are we charging? It says each box, it costs the store $2. Whatever you're selling it for, that's a different story, but we're just looking at the costs, right? We're not looking at revenue or profit. But every time you are paying $2 per box, right? And you're ordering 10 boxes or X boxes at a time. So as I said, if you're ordering 100 boxes at a time, what do you have to pay? Well, the $20 delivery charge plus each box you ordered is $2. So 2 times 100, that's 200. Okay. That's your cost one time, yes? Every time. However, how many times per year are you doing that? There's no 4,000, by the way, yet in the picture. So let me ask you this question. If you are charging, or if you're ordering 1,000 boxes every time, if that's your order size, yes, 1,000 boxes, how many orders per year will you have? Well, clearly 4, yes, because 4,000 divided by the 1,000 is 4 times a year. What if, as I was saying earlier, what if you order 500 boxes every time? How many orders do you have a year? Well, 4,000 divided by the 500 order size will be 8 times a year. And one more. What if you order 100 boxes at a time? How many times do you have to reorder? Well, 4,000 divided by the 100 boxes, that's 40 times a year. So the number of orders is 4,000 divided by how many orders do you make at, or how many you order at a time. Yes, if it's 1,000, then it's 4, right? If it's 500, then it's 8. There you go. So, long story short, try to explain, and again, I've explained all of this one more time in the book, nicely typed. This is our function that we're supposed to do what? Minimize, right? Okay. So I'm just going to put it together. We finally put it together. So this is 1/2 x. By the way, x divided by 2 times 1 is 1/2 x. That looks better. plus 4,000 over x times 20 is 8,000, not 8,000, 80,000 divided by x. Multiply it to 2x, the x goes away, and that's 8,000. Yep. I don't like this. This is what I don't like, the over. So I'm going to rewrite this as a 1/2 x plus 80,000 x to the -1 plus 8,000. So this is the function I'm supposed to minimize. How do we minimize it? Take the derivative, set it equal to 0. So the derivative of 1/2 x is 1/2. The derivative of 80,000 x to the -1, remember the -1 comes up front, makes it a -80,000. X to the 1 less than -1 is a -2. And the 8,000 goes to 0. So there it is, that's the derivative. How do I find min or max? Set it equal to 0 and solve. Okay, so I'm going to keep the 1/2 here. The 80,000 x to the -2 will go on the other side. And just as we did with an example maybe one section ago, what else should I do about this x to the -2? I should throw it back in the denominator, right? That makes the equation better looking. And now I know what to do. What are we going to do? Cross multiply. So 1 times x squared is x squared. That's 160,000. Okay, what do? Take the square root on both sides. And I know it's a plus or minus when you square root both sides of an equation, but so that's going to be a 4 followed by 2 zeros. Can you have a plus or a minus? In other words, can you order a negative amount of boxes? Not really. Okay, so that's why we just keep the positive. Good, we solved the problem. Remember, we've kind of quit on finding the second derivative just to show that this is going to be a minimum. In other words, that the second derivative evaluated at 400 is going to give you a positive. It's going to be a minimum. Okay, so don't worry about that. So this is it. We figured it out. X must be 400. So what was x? The order size. So what's the order size? We should be ordering 400 boxes at one time. So that's the order size. Now, 400 boxes at one time, that means how many times per year? Well, 400 goes into 4,000 10 times per year. That's the best arrangement. Okay, then you have 400 boxes. Start selling them till you get down to 0. Order 400 more, and so on and so on. Okay. This is it. Now, the story can go the same way, and I made up a nice story for you about some dolls. Now, the story again can be made at the same at the other end. Whatever you keep ordering has to be first of all produced, yes? So for example, these boxes of sugar have to be boxed, right? You produce, you make the sugar, you box it, yes, and then stores will come and get it. So how many times should you make those boxes of sugar and wait for stores to come and get them? So this story is not about boxes of sugar, but in the textbook I did make it about dolls being ordered and produced. So the same way on the production end, we want to minimize production run costs. So how many times should you make those boxes of sugars or whatever it is that you're making? So it says, a CD manufacturer estimates the yearly demand for a CD to be 10,000. So in a year, stores will keep coming, and eventually you'll get rid of 10,000 CDs. It costs $400 to set up the machinery for CD production, plus $3 for each CD produced. It also costs the company $2 to store a CD for the year. So how many should be produced at a time, and how many production runs will be needed to minimize costs? So the thing is, you know, stores will come and take 10,000 CDs from you by the end of the year. Should you produce all 10,000 CDs on January 1st? No, because you're producing probably more than that. And you need to store those for the whole year, right? So you don't want to store all 10,000 CDs for the year, right? Of course, you'll keep selling them. But the point is, again, that you want to find that balance. Yes? So again, let X be the number of CDs produced at one time. Whatever it is you're producing, it doesn't matter. Okay. So in other words, the production size. So how many are you going to make at a time, right? Eventually you'll make 10,000 in a year, but should you make 1,000 at a time, 10 times a year, 5,000 at a time, 2 times a year? What do you think? Okay, so there's some costs, and we want to minimize those costs involved. What sort of costs do we have? Same thing, we have storage costs. And we have production costs. Okay, what are my storage costs? Well, how many CDs are we store a year on average? And what's the cost per CD? So again, number of CDs stored times the storage cost per CD. Okay, we know again the storage cost is $2 per CD, yes? But how many CDs will be stored? Again, if we're making X at a time, we're not storing all X all year long, right? Why? Because stores will keep coming and getting some at a time, yes, until we get down to 0. So again, you start with X, get down to 0, make X more, get back down to 0, right? Make X more, get back down to 0. So on average, again, same as with the problem before, you have about half of these X's in storage at a time, okay? Plus, what are the production costs? Of course, the costs per run times the number of runs per year, right? So what does it cost every time you run production? Well, it costs $400 every one time, yes, to set up the machinery. And then it costs $3 each of the X CDs you're making, right? So you're making X at a time, and it costs you $3 for each CD you make. Same thing as the problem before. How many times are you going to run those? Well, 10,000 in the end, split over how many you're going to make at a time. Again, if you make 5,000 at a time, that's only twice a year. If you make 1,000 at a time, that's 10 times a year. That's it. So again, here's your function that we have to minimize. So here's my cost function. All I'm going to do again is put it together. So X over 2 times 2, that's just an X. 400 times this is 400, and then 4 more zeros. 2, 3, 4, 5, 6, 1, 5, 6. So that's 4 million over X plus 3X times 10,000 over X, that's 30,000. The X's go away. Okay, same thing. To prep this for taking the derivative, you might want to bring this X back to the top. So C of X is going to equal to X plus 4 million X to the negative 1 plus 30,000. Okay. So to minimize or maximize something, what do? Find the critical numbers. That's where it's going to happen, right? For these absolute mins and maximums. So the derivative is going to equal to 1. That's negative 4 million X to the negative 2. and the 30,000 goes to 0. Okay. Set this equal to 0 and solve. So you're going to throw the 4 million x to the -2 to save some time. I'm just going to throw it under the 4 million, right? That's where it belongs. The negative exponent means a fraction. And same as with the other few problems we've done, we're just going to cross multiply. So 1 times x squared is x squared is equal to 4 million. Same thing, square root both sides. And again, it would be a plus or minus, except for in this case, the minus doesn't make sense, right? You can produce a negative amount. So x is going to equal to a 2, and then of the 6 zeros, only 3 remain. Okay. So it looks to me like the production size should be 2,000. So in other words, what? Produce 2,000 CDs at one time. And how many times a year would that amount to? So 10,000 in the year, 2,000 at a time, 10,000 divided by 2,000, 5 times per year. Okay. Now, by the way, sometimes it could be funny, and this answer could come up to be, let's say, 1.5 once you divide this. It doesn't always have to come up to be a full number. So what if, let's say, the answer comes up to be 1.5? That's kind of odd. Does that mean you should produce a full 2,000 or whatever it is? Yes, amount of production. And then a second time just half? The answer is no, because it doesn't matter how many producing. There's a $400 production cost, no matter how many you're doing. So you can't just do an order and then just half the order. So 1.5 orders per year really means 3 orders every 2 years. So you have to make it a full order. So if the answer, let's say, comes up to 1.5, that means you do one, right? To do another one more than, right? So past the year. So this is what I'm saying. 1.5 is the same thing as 3 over 2. So in other words, what? 3 productions over 2 years rather than 1.5 productions per 1 year, right? You can't do half a production, right? So you just make it a full amount. You just multiply the fraction, right? You just come up with an equivalent fraction with whole numbers. So that's what that means. Okay, so we're done with chapter 2. Yay! All these word problems and applications are over, but there's more to come in other chapters, so that was fun.